as soon as we got off, I found out that none of Baxum's audio has been recorded. And I personally, this is the sickest part is that that was probably one of the best conversations I've had in recent
Oh my
memory.
God, it was outstanding. I had an amazing time talking to you for a non-podcast.
Yeah,
It's good to
so
get to know you, man.
yeah, I feel like I already know everything about you, but we can just for a little bit, let's just recap the original point of this podcast, how you got into working out. I know we talked about it, but I have some different questions I can ask you.
No problem. So yeah, as far as me getting into working out, amazing question. So one day I was sitting at my I have an older brother, and I was sitting at dinner with my family. I see him like once every month or so. He'll come over for dinner, and I looked over. He's wearing a cutoff, just like I'm wearing now, maybe a little bit less vulgar. But I look over at his arms, and they're just huge. I was like, what the hell? He was a scrawny bitch like a year ago. What happened to him? So I asked him. He's like, dude, it's literally just lifting. And up until this point, on every sports team I was ever on, soccer, basketball, track, I was the weakest guy in all of my sports. Slowest, weakest, everything. And I was like, strength is just genetic. Like these guys just were always stronger than me. They were always been stronger than me. They've always been faster than me. Everything. And then my brother told me he got bigger from going to the gym, and I looked up to my brother. Like he's probably my biggest inspiration. So I was like, you know what? I'll give it a try. So I went to the gym and I started benching. And like a week later, I was stronger the next time. I was like, what the hell? That's crazy. I couldn't bench 95 pounds a week ago, and this is 17-year-old Baxum. How embarrassing is that? And the numbers just kept going up. I kept seeing progress. I remember being in English class one day. I was like reading my book, and I looked down and I saw a bicep vein. I was like, yo, I got a bicep vein. That's crazy. And then I literally fell in love. So yeah, and then it also helped with sports and things like that too.
Yeah, I'd say for me, I'm gonna be honest. Like the biggest factor that was going into why I was working out in the very beginning was vanity. I don't know if it was similar for you. I really just wanted to look good. I really just wanted girls to find me attractive. I was very heavy when I was a kid. My
So
entire
normal,
life.
dude.
Yeah,
Yep, I was the same way.
you're heavy as a kid as well.
I was squishy.
Okay.
I don't know. I wasn't like fat, but like
Yeah.
yeah. I mean, I just wanted to be attractive. You know what I mean? Like going to bed and not feeling happy in your body. It's such a normal thing. You know what I mean? And then all of a sudden going to bed and being happy in your body. You know what I mean? It's life changing. It really is. I completely understand.
I do feel like that vanity aspect has really changed for me, though. I feel like now, if you were to ask me why I go to the gym, the way that I look can't even crack the top five of reasons why. I don't know if that's the same for you, but I would say it's very interesting how we all get into the gym the same way almost, and we all come out very differently.
Dude, yeah, that's so true. I'm trying to think about why I still go to the gym, and I think the biggest reason now might just be like life structure, just to have something to do every
Part of your
single day.
identity
You know
at
what I
this
mean?
point.
Yeah, it literally is. I mean, I to look good is still definitely my top five. I definitely am training to get bigger arms and bigger
I
everything.
guess that's kind of not true. Yeah, I guess definitely I care about it.
But I don't know if it is number one anymore, because like in a year's time, I don't look that different anymore. You know what I mean?
Yeah, and it gets to a point as a natural, especially where you're really not in it for the games anymore. You can't be. I mean, even if you are, you're not making them. Especially after
Right.
like I would say 10 years of hard, consistent, good training, it'd be very hard to put on any more than a couple of pounds of muscle after that point. So
Yeah.
you really genuinely have to fall in love with the aspect of trying very hard. And I think that is something I'm trying to instill in my clients every day. And it's very hard when people have spent their entire life, at least in my case, when I work with mainly the elder population, a lot of people have spent their entire life avoiding difficult situations, both in real life and in physical life. Sorry, both in our, work lives, our societal lives, and physically. So I think it definitely does, and people talk about this all the time, how like bodybuilding and training can impact other aspects of your life. It truly is the essence of what we try to do in everything else anyway. Get better,
Right.
expose
Absolutely
ourselves
agree.
to higher degrees of stress, higher degrees of difficulty, so our bodies and our brains can adapt to doing more.
And I think you made a beautiful point in there, which is we do this for enjoyment. And that's a big argument in the science-based lifting community right now. Is I am known as what is called an enjoyment cell, where for new lifters, I think that the most important thing that you can teach them as a coach is enjoyment. And the reason I believe that is, and we talked about this earlier, but the reason I believe that is because if somebody comes to me and they want to change their body, they want to lose weight, they want to get bigger, they want to gain muscle, whatever it is, and they've never been to the gym, I win as a coach if in the first 6 months I'm able to get them to fall in love with the gym. Even if they have the least optimal training of all time, if they are in love with the gym and they are going consistently on their own, and I don't have to keep pushing them to go to the gym, I have won as a coach. Even if they're not doing optimal training, they will be making progress. They will be changing their body and changing their life. And that is what my job is as a coach, which is why I preach enjoyment number one.
Would you say enjoyment is the most important factor?
I do, actually, yes. I have a video, it's my majoring in the minors video, where I list out how important every factor is at the gym, and I put enjoyment, which in parentheses I then put consistency, as number one. If you cannot enjoy the gym, and you cannot stay consistent at the gym, which comes from enjoyment overall, even if it's just enjoying the results, you will not make progress. You need to be able to go to the gym to make progress. The number one thing that matters to make progress in the gym is going to the gym, which stems from enjoyment and consistency. So yes, I would say it's number one.
So I know we talked about this in the previous podcast, but I just want to get somewhat of a deeper idea, deeper understanding of where you do draw that line between science-based principles and just training for pure enjoyment. So like, obviously you have a lot of experience in engineering. It's kind of straying from my original question, but I'd also just like to know how that engineering impacts how you view science-based lifting, and if that makes you kind of consider enjoyment a little bit less because now you know kind of the way that things work mechanically.
Yeah, so that's three amazing questions, I'd say. So first, where do I draw the line in science-based lifting for me and for a new client? And I'll start off with a new client. So a new client comes to me at the gym. What am I going to preach them, right? They've never been to the gym before. And every single time it is going to be push-pull legs, and I'm going to tell them squat, bench, deadlift. You're going to squat every leg day, you're going to bench every chest day, and you're going to deadlift every single back day. Why is this? It is the least optimal form of training. Also leg press. I also preach leg press instead of squat if you would prefer on your leg day. And the reason I do this is because these are all heavy movements that you're going to progress in weight extremely quickly, and most importantly, they are enjoyable. What is the number one question that people ask new lifters back and forth? How much do you bench? Without fail, every single time. Because it's enjoyable and it's like the thing that everybody cares about. It's what you want to progressively overload. When I was a new lifter, I wanted to bench 135 first, and then 225, and then 275. That was all I cared about. And that is why I kept going to the gym. So I'm going to preach this thing as it is going to get you into the gym, and once again, it's my job as a coach to get you into the gym. And then further down the line, I'll get into more optimal training. As for myself, where do I draw the line? I am not going to do things that I don't enjoy or that are going to factor or make me eliminate more important factors in my training for improving a lesser one. For example, exercise selection. I'm not going to do Keenan flaps, even though it is a more optimal exercise in my training, because in order to do Keenan flaps, I have to sacrifice more optimal parts of my training. For example, Keenan flaps, I cannot properly progressively overload. I max out the cable. Even though it is a more stable movement, it has a better resistance profile than lat pull down, I cannot progressively overload it. And on top of that, I am not incredibly stable when I'm doing Keenan flaps. I'm lying on a bench, the bench is kind of in the way, and it feels a little bit awkward. Keenan flaps, even though they are the most optimal movement for your lats scientifically, for me, do not make sense given my current gym and the way that I have to set it up. So it's really just gauging optimalness and like actual practical factors. And then the final question you asked is the engineering side. No, I mean, I would say more the way my engineering mind affects the gym is anytime I choose an exercise, the first way I think about why I choose an exercise is on the physics side. And a great topic as an example is going to be neuromechanical matching. I'll get to that in a second. But the first thing I'm always thinking about with exercise selection is going to be resistance profile, because that's just how my brain works. My brain works in sines, cosines, tangents, and angles and things like that. With machines, the first thing I do, and I'm probably the only guy in the science-based lifting community who does this, is I look at the cam and I go, oh, that's a big cam. Oh, that's an oval cam. Interesting. This is a descending resistance profile. Like, who the fuck does that? So so I don't know. You can call it autism. You can call it whatever. I just call it a physics-based brain. But I'm basically choosing exercises that I enjoy the physics side of. And when I'm choosing exercises, I'm not thinking about the biomechanical advantages and disadvantages, which might hurt me because that's maybe more important in exercise selection. I'm more thinking of the physics side and the like resistance profiles and things like that. And just to kind of explain what I mean by like my physics brain could be overcoming my biomechanical knowledge or whatever. Neuromechanical matching is a mostly biomechanical argument. I do not understand how muscles work. I don't to me, muscles are springs. And as an engineer, the way I like to think about neuromechanical matching is if you had two steel beams and your muscles were individual springs, as your muscles primarily act as springs, the muscle that is most advantaged, or the spring that is most advantaged, is the spring that has the highest change in length during the activity. So if I had a spring here and here, here to here, and it was a little bit twist, and I had a more linear spring from here to here, the more linear spring will change in length more than the more twisted spring. Therefore, the more linear spring is going to be doing more work, and in my brain, I equate that to muscles. So therefore, the muscle that is the most advantaged is the one that is the most linear and has the most change in length during the exercise. So that is how I attacked the whole neuromechanical matching idea. I could be completely wrong, but that is kind of how my engineering physics perspective falls within the science-based lifting community.
Now, would you say that things do get more complicated, though, because muscles have nonlinear force properties and aren't exactly equatable to like rubber bands or springs or something like that?
100%. And that is where my knowledge falls off a cliff, right? A good example is Braden Whitworth. I've had a few conversations with him, like off camera, on neuromechanical matching, and he understands much more than I do how muscles work, types of fibers, and things like that. I just know how steel beams and springs work, but I do have the knowledge to at least admit that muscles are different than springs.
Right.
I don't understand how they're different, but I feel like if I was able to understand that, I would be able to give a much better answer. But instead, I'd rather just say, hey, this is the physics side of things. Logically, this muscle should be doing more work. But hey, you know the biomechanics side more. How about you tell me that part? And I would love to work with people in the community to come to conclusions that way.
Yes, because I absolutely agree with you that from a logical efficiency standpoint, it makes so much sense that the central nervous system evolutionarily would grow to prefer to use muscles that have the greatest mechanical advantage to do something in order to reduce the amount of effort it would have to output. So it makes a lot of sense. So I understand where like people have taken the idea of neuromechanical matching and ran with it. I just think that we have to take into account the fact that muscle force is non-linear and it's not something that we can really equate exactly to a spring. There is such thing as the length tension relationship. Cross-sectional area does play a factor. So
Also, the angle of insertion matters as well, because what you're doing is a torque about a joint. You're not doing a linear force at that joint.
Yeah.
So the actual angle of insertion is going to change as well as you go through the movement. So not only is your muscle a nonlinear relationship, but this angle of insertion is also a nonlinear changing relationship. But when you factor all of these things in, the actual like force or torque versus length is going to be a second order equation for every single muscle. And I would be so curious to find these second order equations at all these different angles theta at every single joint. And all I can do is help with the physics side of that, which is unfortunately the more minor side.
yeah, and it's important to note, even though we mentioned it obviously in the lost footage, but some muscles that are like pennate in nature or have different shapes may change internal moment arm lengths depending on how much they hypertrophy. So it's possible, like in an example of the quads, since all four heads of the quads have vastly different internal moment arm lengths in different positions, it's possible that if one head of the quads hypertrophies more than another, it could possibly receive greater recruitment from the central nervous system. So that may also cloud up certain things with neuromechanical matching, but I am definitely not educated enough to go in any more depth about that, and I don't think you are either. So
I wasn't educated enough to go that in depth on that. So yeah, you're already beyond me, man. I can't add anything to this conversation. But yeah, I do understand everything you said, but I couldn't have come to that conclusion myself.
if you had to say, what's the biggest programming mistake you see online?
Biggest programming mistake? I think there's a lot of programming. That's an amazing question. I think there's a lot of programming mistakes. I think the biggest one that I'm seeing right now is just this not majoring in the minors thing that I touched on really heavily. And I've talked with Trell about it on live a few times. But people are really focusing, and what I mean by majoring in the minors is if we had a list of all of the things that you can improve your training on, right? Sleep, your diet, going to failure or intensity, and it kept going down. The things that people are talking about in the community the most and nailing the most are things like stability and exercise selection, which fall all the way down here on the list. And a lot of the people that are really nailing those two things are really missing a lot of the bigger picture things that are more important for their gains. And this is why we see the bro lifters or the ooga booga lifters, as I've referred to them on my channel, making more gains than some science-based lifting creators, because these science-based lifting creators, while they're super smart and absolutely nailing these more minor things like exercise selection and things like that, they're completely missing the mark entirely when it comes to things like their diet, their protein selection, their sleep, and things like that. So to me, just as a community, if we could really focus on majoring in the majors first and then adding the minors later, I feel like we would see a lot more progress in our science-based lifters as a community. And I'm not saying everybody does this. 90% of people are able to major in the majors and add the minors. But there's a very loud 10% that is majoring in the minors, and that is kind of putting like a bad image on our community almost a little bit.
And it's definitely worth noting that there's just as much outcome data supporting 3x over 2x than there is outcome data supporting a high protein intake over a low to moderate protein intake.
Yeah, so this is something that we touched on earlier. Keenan Malloy, to me, is the ideal picture of a maximalist in this community. He's doing things that aren't proven to increase gains, but are most likely to increase gains. And he believes that in the future, as more research comes out, it will be proven that these things add more gains. But a few things that I disagree with Keenan on is he is a maximalist in the form of full body every other day. His code on every single thing that he has a code for is FBEOD, full body every other day. He's a full believer in full body every other day, even though it's not proven to be any better than 2x frequency. But my issue with Keenan, once again, I love Keenan. We've spoken a million times. I would consider him one of my best friends in this community. But one of my issues with him is he doesn't hold the same maximalist ideology when it comes to things like protein. So if we look at the biggest protein study, it is going to be Morton 2008. It is a meta-analysis. And if you look at this study, as you eat more protein, it's almost a linear relationship. More protein, more muscle, all the way up until you hit 1.6 grams per pound of body weight. And then boom, it's flat. That doesn't make sense to me. There's no reason that our body knows, oh, we had 1.6, time to level off. To me, it should be some sort of second order curve at some point. So what I did is I looked at all of the studies past 1.6 grams per pound of body weight in the study. And what I found was that the ones that lie above the curve, these are very good programming, better splits, more sets or more optimal sets, closer to failure and things like that. But the studies that lie below the curve, past 1.6 grams of pound per body weight protein per day, these had not very optimal programming. And I feel like that explains why we were seeing this almost flat level off, because if we had more studies that had more optimal programming, I feel like we would continue to see that graph go higher and higher and almost have more of a curved level off in the future. And it's because we have so few studies past 1.6 grams per pound of body weight protein that we see this almost flat conclusion. And I think that is the wrong conclusion. And as we get more studies in the future, we'll see that more protein does in fact lead to more muscle. And that's something that's kind of annoying me about the community, is we've almost settled on 1.8 grams per pound of body weight protein as this equal amount to 2.2, when in reality I believe that 2.2 grams per pound of body weight protein every single day will give you more muscle. And I'm a little bit frustrated with the conclusion that we've come to.
Yeah, I would say it's just, once, like you said, it's just as much reasoning behind the 2 and 3 times frequency. If right. I feel like the evidence might even be stronger for a higher protein intake than for 3 times frequency being superior to 2 times frequency.
I agree. So if we're going to be true maximalists, once again, I'm using Keenan as an example here. I love Keenan, but I feel like, and also I do want to say, Keenan looks at this research more than I do, and I don't know how far he looked into this protein thing. I could be completely missing something. This is just some dots that I connected, and I would love to find out that I'm completely wrong. 100% love to. And I'm sure Keenan believes what he believes because there's something that I am missing, but this is just something that I've noticed. So I would love to have a conversation with Keenan about this. But if we are being true maximalists, we know that more protein can't hurt your gains. So why are we limiting our protein to 1.8 grams per pound of body weight? Why are we not increasing that further? Because it could give us more gains. Yeah. It can't hurt them. So why not take the risk at more gains? Worst case, more gains, or sorry, worst case, equal gains, best case, more gains, versus less protein, worst case, less gains, best case, equal gains. Yeah. The obvious option is more protein.
Yeah. And it is very hurtful to see online, like, people that are more likely to cuff or strap their arm to the cable stack in order to do a tricep extension and not even hitting a gram of protein a day. And this is kind of like putting the cart before the horse kind of thing that you were talking about, that plenty of creators have talked about. But that's the real issue. And another issue that I see with these single joint movements that a lot of these people are doing, which I know we talked about, but files are gone. But a lot of people, when they find these single joint exercises that maximize hypertrophy, that have the perfect resistance profile, that have the perfect range of motion, perfect joint angle, they're often extremely easy to max out. And if you've been training for more than like 4, 5, 6 years, going on 10, you should, if you're training with the proper principles, you should already be pretty strong on almost every machine in your gym. If you're experiencing progressive overload properly, then you should be too strong for a lot of these exercises that you see on the internet. And I'm not saying Keenan flaps are a bad exercise at all. If you can find a way to execute a Keenan flap with proper load and proper progressibility, by all means, do it. It's probably going to be better than a lat pull down marginally. But
yeah, I 100% agree. I mean, I did Keenan flaps for a while. I ended up maxing out my cable stack. I can't use a gym pin, so I went back to a wide grip lat pull down. Keenan flaps are objectively a better exercise. It has a better resistance profile. It has better range of motion. It's objectively better than lat pull down. My issue is I cannot progressively overload it, and it's a little bit uncomfortable, and I don't feel as stable doing a Keenan flap as I do a wide grip lat pull down. So I will take the added bicep stimulus, which is going to decrease my lat stimulus a little bit and make my lats grow a little bit. Once again, we're talking about like 5% difference max, 5% less growth with my lats. I'll take that just to have more stability and better progressively overloading, because at the end of the day, those two factors are more important and will lead to more gains down the road.
And people also forget that when you make an exercise unilateral, you're reducing the stability of the exercise. So if you think about like a lat pull down compared to a Keenan flap, yeah, if you have the ability to properly execute a Keenan flap and it's loadable, then yeah, it's probably going to be better than a lat pull down. But if you have to load that Keenan flap so much, and it's a unilateral exercise, it may reduce the amount of stability you have that may make the bilateral lat pull down more stable and better even at a higher load. Even if you could find a way to load the Keenan flap more, you may end up having to use so much load just due to the less total force production that you're going to make the exercise so much harder to execute.
Yeah, Coach Kessam actually had an amazing point on this that went kind of viral, and that was he's seeing a lot of people. I don't want to use the names that he uses as an example, but they're doing these cuffed tricep pushdowns and their shoulder is coming up. Right? Why is that? Right? You can't be stable in what is supposedly a more stable exercise. And the issue is when you move from holding a handle and you move to a cuff at your wrist, you're shortening your moment arm by a couple of inches. Well, it's just a couple of inches, Baxum. That's almost nothing. Yes, but when we decrease our moment arm by 2 inches and the entire moment arm is only about like 9 inches, that is 22% of our entire moment arm. That increases our torque by over 22%, almost 30%, or sorry, that increases our shear forces by almost 30%, and our shear forces are our lat holding our shoulder in place. So if we are a less experienced lifter, and we can't do proper form while holding the handle, proper form will be even more difficult when we cuff it at our wrists. And this is something that I'm seeing in a lot of our community. And it's kind of disappointing because they're saying black and white, yes, cuffs are better than not cuffs, but it's not a black and white issue.
Yes.
For some people, cuffs are better. For most people, experienced left lifters especially, cuffs are better. But when you make it a black and white issue, you're hurting beginners who are now adding these cuffs, and they're having worse form and actually hurting their gains by using them. And this is coming from somebody who's sponsored by Echovision, and my goal is to sell cuffs.
And we're reinforcing this idea that, you know, we should just look to remove as many joints as possible, and that's fine. That's a fair idea for hypertrophy, but we sometimes get so obsessed with that we sometimes forget that we want to keep the external moment arm as long as possible to increase the amount of torque and reduce the amount of external load we have to use. Like, a perfect example is like a lateral raise. Have you ever seen people put cuffs on a lateral raise? My personal issue with that is that the line of force on a lateral raise is going to be moving straight down, directly down, right? If you think about the way that people do a lateral raise, what direction is the elbow joint pointed in? Perpendicular to the line of force. The elbow joint really isn't involved in any isometric contractions for flexion or extension during a lateral raise. There's really no reason to put the cuff at your elbow for a lateral raise unless you just want to increase the load by 2 times, which is going to make the exercise less stable. No question about it.
I've never thought about the fact that the joint is perpendicular. That's actually an amazing point.
Yeah.
I've never thought about, you literally cannot have bicep stimulus if that joint is perpendicular. I will say though, cuffing at the wrists will eliminate the forearms, which is not perpendicular.
Yeah, I agree. I would cuff at the wrist. Yeah, I would definitely say, and it's the same thing for kind of like when you do cuffed extensions. I see so many people do like neutral grip cuffed extensions. Why, if you're doing a neutral grip cuffed extension, are you putting the cuff at your wrist if your wrist flexors and extensors aren't involved in the extension anyway because you have a neutral grip? And then people will say like ulnar and radial deviation, but that's irrelevant. That's such a tiny. There's not even. We don't even like that. The amount of force production that creates is not even 95% of what that exercise is. So
exactly, 100% agree. 100% agree, man. Yeah, I think people are just taking it a little bit too far.
Yeah, I would say that's the problem. Is because people don't even think about the basics first, and it's immediately the thought is, okay, let's just take as many joints out of it. But in reality, what the thought is let's see how much weight I can truly put on this machine, how much weight I can do and feel strong about it. And we're forgetting that, like, yes, we're supposed to get stronger. That is the end goal. But it's getting stronger with the same variables. Like, we have to keep all the variables the same. We're not just getting stronger. We're not just going and putting as much weight as we can on the machine.
I've never even thought about the ego lifting aspect of moving down our moment arm to increase the weight. I've never thought about that, but I could totally see that being psychologically what somebody's doing, right? Hey, if I cuff this at my elbow, I can do more weight.
Yeah.
Look at how much stronger I'm getting.
Look how much more force I'm creating.
Yeah, you're decreasing the distance that weight is traveling, so of course the weight has to increase to accommodate that. At the end of the day, the torque generated by your shoulder is exactly equal, which is what is actually causing that mechanical tension in your muscle, despite what Yo might argue. Sorry.
No,
I do not hate Yo, by the way. It's just something he continues to argue in videos that he makes about me, is that torque is irrelevant to mechanical tension, but it's actually the entirety of mechanical tension.
I'm not sure if I get that. I didn't understand his linear force video either.
Well, it was wrong, so it's a good thing you did not understand it. It was incorrect.
Because, like, aren't all muscles kind of rotational forces?
Yes, so every muscle is going to act across a joint at some point.
Yeah.
And what happens at joints is rotation. So what that muscle is doing is creating a torque about that joint. That is what is moving my shoulder up right now. That is what is moving my elbow out right now. Your muscles are creating torque. They're not creating linear force. So by increasing the linear force, all you're doing is creating more shear forces, which your muscles are not actually actively moving by moving a joint.
Worse for your tendons, though, probably, right?
I can't speak on that, to be honest. Maybe I don't know for sure. I'm not a biomechanics guy. But what it will do is the supporting muscles. For example, when you're doing a tricep push down, what is holding your shoulder, right? Because you have a weight pulling up, your shoulder wants to go like this. So the thing that has to hold that down is going to be your lats. So your lats have to stay activated the entire time. And if you're decreasing that moment arm, you're increasing the shear forces, and the shear forces are what your lat is holding. So by decreasing your moment arm, you're increasing the supporting muscles usage, actually, which for all my science-based people out there, well, I don't believe that heavily in this, CNS fatigue, all this other stuff, you know what I mean? Because you're increasing the amount of work that your lat has to do. It's essentially an isometric for your lat.
Yeah. And I definitely wouldn't say that it makes sense, just from a logical perspective, too. If we're trying to get stronger and as strong as possible, shouldn't we want to be doing as little of an external weight as possible so we have more room to get stronger? Because the shorter you make the moment arm, like, you're going to stack the machine fast, dude. Like, if you're an experienced lifter who's been training properly, you should have trouble finding machines that are heavy enough in most gyms. That's true.
100% agree. 100% agree. Have you actually have you seen that product that is coming out? It's the cam extender.
No.
There's two creators, Loizic and Carter. One is French, I believe. Oh God, I'm so sorry, Loizic, if I got that wrong. And the other one is Carter, who's an American somewhere. But they are creating this product. It's essentially a ramp It's almost shaped like that. And what you can do is you can clip it to the cable of a machine. And when it comes up to the cam, you're increasing the length on that cam at that point, which increases the amount of torque on your muscles. So it's essentially a gym pin because what your muscles are doing is
Wow.
countering torque. So with gym pin, you're increasing the weight to increase that torque, as torque is weight times distance. With this, what you're doing is you're increasing the distance on that moment arm that the weight is acting on against you. So it's another way to increase the force without adding wear to the cables, or a lot of machines you can't fit a gym pin on. So this is another way to increase that torque with on machines where you can't use a gym pin.
And it also
I
doesn't
think it's
add
absolutely genius.
it doesn't also add stress to the cables, which could potentially cause the cables to break. That's actually genius.
Exactly. It is genius. And here's the best part. It is a increasing the torque only at the point in the cam at which you are adding this device. So what you can do is actually change the resistance profile of your machine at the same time. So by using multiple of them, you're increasing the force everywhere. But by using only one or two, what you can do is increase the force at just the beginning of the exercise or just the ending of the exercise to create an ascending or descending resistance profile on any machine that you would like.
Bro, well, is it out yet? I'm literally gonna buy it. Like, I'm literally about to buy it. Like, you
It is
sold me.
not,
You sold me.
dude, I know it's like, where's my commission, guys? I'm just kidding, but they're still working on it, improving it to make sure it's durable because this thing is experiencing very high forces, and they're making it out of 3D printed plastic, which PET is not the strongest.
Yeah.
But I think the first person who's going to get one is going to be Jackson, Scientifically Jacked, as I believe he is coaching Carter. So he's number one, and then I've been talking to them a little bit, and I'm pretty high up on that list as well, thankfully, to try it out. And I think it's because I'm the physics guy in the industry, and this is a physics-based project. So very excited for that.
It's literally amazing.
It's super cool. And here's the best part, actually. This is where I started this conversation, or started this point. A gym pin is like a 3-pound pin or whatever that you have to carry around in your bag. It's heavy. It's annoying to carry around. This is a 15-cent little thing that you can put in your bag, and you could have 10 of them in your bag. It doesn't take up much space. They're much more convenient than a gym pin. I feel like in every aspect of a gym pin, this is an improvement, and I think it's the greatest product idea I've ever heard of.
Yeah, and I'm not even allowed to use a gym pin at my machine. Sorry, I'm not even allowed to use a gym pin at my gym because of the extra force that it puts on the machine. It could potentially damage it, and they have expensive machines.
Yeah, I've
So
snapped cables before.
I could literally use that at my gym. But that fixes a huge major problem for a lot of experienced lifters. Like
Dude, I know.
that's almost more innovative than the gym pin.
I would agree. I mean, gym pin is a genius product. Don't get me
Yeah.
wrong, but I mean, this is just levels more cool. I think it's beautiful. Beautiful. I'm excited to see it.
Oh, wow. Are they gonna releasing it to sell after they send it to you and Jackson to test it?
Yeah, I mean, mass production. I don't know how much you know about just making products in general. I'm an engineer, so I've worked at a few assembly lines and things like that. Mass production is not easy. These are two, I believe, younger than me people who are trying to make a product. It is not easy to mass produce this product. So I don't know what they've thought about on the mass production side. I would be extremely happy to help them as somebody who's worked on multiple assembly lines to plan that out, but it's very expensive and it's very complicated. So I believe what would happen is first they would send a couple to me and Jackson, and other creators as well. It's not just me and Jackson, to try out and build the hype for it, advertise it, things like that. And then I think what would happen is they would try and make more and more, and continuing to improve the product as they can, and literally just have drops. Like, hey, we're selling 15 of them this Saturday. That's all we could make this week, and it's gonna be a hot grab for getting those 15. So the markups at the beginning, if they're smart, are going to be incredibly high, and they should use that profit margin to try and build towards some form of automation and mass production.
Yeah.
Which is this I'm hoping to help them with, and I don't expect any commission or anything, but I'm hoping to help them with it.
Yeah, that's got to be easy to mark up because that cannot be expensive to produce.
No, I mean it's like 38 cents in PET probably, and a couple bolts that are 5 cents each, and I mean I'd be willing to pay what I paid for my gym pin for this product. I'd be willing to pay $45 for 3 of them, easy.
Oh,
And
I'd pay
that
more than
profit
that.
margin-
I'd pay more than
Yeah,
that.
that profit margin is insane.
Yeah.
We're talking about $1.15 materials, $45. That adds up quick. Yeah.
Yeah.
And of course, I mean, they deserve some profit as well. So I mean, if they're taking 10% cuts of this, $4.50 each, which is a completely fair cut, I mean, that is 80% of the product revenue that you get to spend on improving your business. Very exciting future for them. I'm excited to see where it goes. But I will say they're not the only ones working on the idea. I've had other people DM me on Instagram and other platforms saying, "Hey, I thought of this idea," and I'm like, "Hey, people are already working on it." So
Get to it.
yeah, I don't know. I don't want to help other people out too much because I mean, Carter and Loisik are my boys. They're part of the community. But I am excited to see where the product goes.
Yeah, me too. And I definitely gotta drop them a followers on that. You gotta share me their socials after this.
Yeah, I can definitely do that. I'll send you their info. Maybe you'll probably put it on the screen or something.
Yeah, I'll drop it on right now.
But yeah, I made a couple videos on it. It's super super cool. Excited to
I
see where it ends
I
up.
also have beef with small cams as well. Like I don't understand like who designed some of these
Yeah.
machines.
I know some of them. So with some small cam machines, the reason is because as you make the cam bigger, the weight has to travel a larger height.
Mhm.
So if you have a larger range of motion within the machine, you're going to need a smaller cam. Otherwise, the machine would be 15 feet tall to allow for the weight to travel that high.
Mm.
You know what I mean?
So then,
So that's sometimes, but sometimes the cam is small and the weight is lifting 6 inches off the pad, and it's like, well, this is just a terrible design. Can we use all this weight that you've allowed for, or all this space that you've allowed for?
yeah.
Thank you.
Would you say
Yeah.
like is there like a genuine engineering excuse for the fact that most commercial gym or gym machines are too light, or would you say that it's just the companies don't know what they're doing?
Uh, Cheapness is really the biggest
Mm.
one. Plates, it's all cast iron, and cast
Yeah.
iron sells it. I mean, it used to be $1 a pound. It's getting closer to $2 a pound now.
Yeah.
That's the most expensive part of the gym equipment. In my senior design project and my sophomore design project at Purdue University, I was designing gym equipment, and the most expensive part of all of them is the plates. For example, our senior design product was about like I want to say $1,500 cost, and I think 1,000 of that was the weight. So just adding more weight is adding directly to your cost pretty heavily.
Yeah, I know that personally because first time I started working out, I actually wasn't even in a gym. I was just in my basement, and I bought like cement plates. Have you ever heard of like cement plates before?
I have,
Yeah, because they were way cheaper than metal plates, and at
yeah,
that time, metal plates were probably like $1 a pound, and now they're
but they're
definitely
a little
even
bit
more.
less dense, so you're going to need bigger plates, more
And they
space
would also
for the same
chip.
amount of
They
weight.
would chip after every single rep that I would do on
Ooh,
deadlift.
true.
So the weight
Yep.
would just get less and less. I was progressive underloading. Like,
That's hilarious. That's awesome. Yeah, I've never actually seen concrete plates before, though. I didn't know they were sold
because I bought them on Facebook
commercially
Marketplace.
like that.
Some guy, no, some guy literally made them
Oh,
in his garage with a mold.
that's awesome.
Yeah, and he weighed them in front of me too. He was like, "No, we can check to see if they're real." I mean, they were on point. Like most gym plates are off by like a couple pounds if you actually weigh them. His were on point
Really,
when he
a
gave
couple
them to me.
pounds? I
I
didn't think it was
believe
that large
so.
of a
Maybe not
margin.
maybe like a pound or two. Honestly, it might be like a pound or two.
Interesting. I would assume they have. I mean, it's pretty standard in engineering to have within a 10. Oh, with weight though, it's not going to be 10%. It's pretty standard to have with a poured plate, probably a 2.5% margin. So yeah, I mean, I guess that does weigh out to about a pound either way. Yeah, that checks out. That makes sense. I've
Huh?
never thought about that.
Yeah. I mean, so why is that? There's actually a physics explanation for that.
Yeah, it's more of an engineering explanation. So, I mean, if you're going to make something an inch long, it's impossible to make it exactly an inch long, right? There's going to be a plus or minus there. And when you're mass producing something, you have to make it quickly. And it gets even harder to make this one exactly an inch, this one exactly an inch. You know what I mean? So, with my company, I work in the oil and gas industries. We're primarily buying pipes. And the thickness of the pipe is extremely important because we're withholding extremely high pressures. We're literally an explosion factory where our job is to make sure explosions don't happen, right? So, we're withholding extremely high pressures. And the thickness of the pipe is the most important part. But within that thickness of the pipe, the company is allowed to be plus or minus 12.5% of the thickness of that pipe, which is an extremely high amount.
Yeah.
Like I could be buying a pipe that is half an inch thick, and it could be a 16th of an inch less thick. That is a incredible margin, and that's just set standard by code. And there's different codes for every industry. I don't know what it is for the plate industry, even if there is a code that just allows certain companies to fall within a certain margin either way for measurements and things like that, just because it's impossible to make everything perfect. So what is the standard that we accept?
Yeah.
And these companies will usually post their standard. I'd be curious what like a standard road plate would look like.
Yeah.
But I know the Olympic plates have tighter margins because they're used for competition. Those like red, green,
The
whatever
calibrated ones
plates.
you're talking about. Yeah.
Yeah, calibrated plates. So they'll just have a tighter margin. But even them, like if you buy a 55 kilogram plate, it's not going to be 55 kilograms, right? It could be 55.1, it could be 49,
Yeah.
or you know what I mean? Just because it's impossible to be exact.
And would it probably be not even worth the money to try to like get as specific as possible?
Exactly. I mean, when you're doing engineering, it's not getting everything 100% correct.
Yeah.
It's about getting things 80% correct while spending 20% of the time on it, right? If I want to make something 5% better after 80%, I have to spend double the time as I spent to get it 80% correct. And then another 5%, double the time yet again, and so on and so forth.
The amount of effort you have to put in increases exponentially the more you progress.
Exactly. It's a standard deviation thing. There's a common software that you can get what's it called? Certifications on, known as Six Sigma. What Sigma is standard deviation. It is the symbol for standard deviation. So if I want to make sure that everything lies within one standard deviation of the mean of accuracy, I have to put in X number of hours to do so. 2 standard deviations of accuracy, so even more accurate. I have to put in so on and so forth. And with like the airline industries, they're pushing towards Six Sigma. They have to be extremely accurate because everything that they make has a factor of safety of about like 1.1. right? You're thinking, wait, but planes have to be ridiculously safe. I'll explain what factor of safety is first. So if a factor of safety is less than 1, something will break upon use. If it is exactly 1, we are stressing the material to the exact amount that it can withstand. And if we are above 1, we have that factor of safety of like 0.1. We are going within 10% of the failure amount, if that makes sense. So airline industries have extremely small factor of safeties because in order to increase the factor of safety, you have to make parts thicker, bigger, out of stronger materials, more expensive materials, and everything like that. And airline or planes cannot be heavier. They can't. They have to stay in the air. So they have to make everything as small as possible to have these small factor of safeties. And because of this, they have to have extremely low margins of error on all of their parts, which is as close to 6 sigma as possible.
So would that mean that they have to replace their parts more often or no?
Yes and no. It's more I'm more talking about in the manufacturing setting when the plane is actually built, how close it has to be. Like if you've ever looked at an airplane turbine, if there's a tiny little dent in just one of those little things, they have to scrap the entire part.
So does that kind of apply somewhat to like kind of cables on machines though? Like is there like a limit to the point to the amount of like stress that a cable can take before it kind of falls apart? So like in theory, every machine will break at some point after somebody uses it.
Right. So now we're getting really into engineering. I love this question.
Yeah.
So first of all, if a cable is rated, typically the gym cables are rated to about like 300 pounds. That's why we see a lot of machine stacks that go up to 260, 245. It's just under this 300 pounds, right? But they usually have a factor of safety of about 2. This is why you can put a gym pin on and increase the load closer to this true weight that it can withstand, which is 600 pounds, right? If it's 300 pounds that it can withstand, if it's 600 pounds that it can withstand, factor of safety is 2. The weight that it's rated to is 300 pounds. It's the number it can withstand divided by the factor of safety. Does that make sense?
Yeah, it does. Yeah.
Sorry, I completely blanked on where I was going with this. What was your original question again?
About how like cables, like in theory, all cables are going to break at some point after somebody uses them.
Yes. Okay, so now we get into something known as stress fatigue. This is the most common way that things break over time. So there is a chart with every single material that shows on the x-axis it is number of cycles that it has withstood, and on the y-axis is the maximum force within each cycle. So what you can do with the cable is you take the material of the cable and you can take the average maximum, let's just say people are maxing out the machine every time, 250 pounds. So you would go up on the y-axis to 250 pounds and you would go out to the x-axis until you hit this charted line. And wherever you hit that line, that is the number of times this cable can be used at that weight before it would break. And the way that line looks is it is basically an inverse of the protein line from the Morton study that I was talking about earlier, where it's a constant decreasing line and then it magically gets level. So what that means is if we stay below where it gets level, the cable should never break. For example, if you put 5 pounds on a cable, you could move that 5 pounds infinite times and it would never break. But eventually you hit a weight where eventually if you stress the cable at this weight enough times, it will break.
And is that weight at the max of most cable stacks, or is it with probably a gym pin and a couple pounds added?
My guess is because for cheapness, just because cables are pretty cheap and they break pretty often and are easily replaceable, the maximum weight on the cable stack is at a point where a certain number of cycles at that weight would break the cable.
That's actually fascinating, though.
Yeah. The other thing is that's just factoring the actual weight on the machine. You'll notice these cables have a rubber lining. If you look at an older machine, this rubber lining gets worn out by the pulleys. This is because friction will wear things out a little bit faster. So when you have friction on the cable, first it's going to take off this rubber lining. Once that rubber lining is gone, it's going to slowly make the metal thinner and thinner at that point over time. So where cables will break the most often is at the points that it is touching the pulley the most often, as this is where the cable is the thinnest, and when it's thinner, it's a little bit weaker.
Wow, and it's constantly experiencing that friction.
Exactly.
Yeah, wow. Huh. So I find it's so interesting, like, you know so much about like cams and like machines because you're like an engineer, but like it's so interesting how like you could be educated in a certain field and then just know so much of like one tiny aspect of something like fitness. Like this applies to like a small aspect of fitness, but you know so much about it that it's allowed you, I feel like, to make inferences on the rest of fitness, you know?
Right, exactly. Yeah, but then if you ask me like what the force distance relationship of the tricep looks like, I'll be like, I don't know, ask Yo, dude. Yo knows that one. I'm willing to admit I don't know anything about that. So, yeah. That's Yo's expertise.
Do you think some people are missing out because they don't know the mechanical aspect of things? Or do you think that it's really just your passion and you like that it somehow is involved with what you like to do?
Yeah, I mean, obviously, I think it's important to be, if you want to be a supreme educator in this topic, it's important to understand every single subtopic as well. And this is one of those subtopics. I do think it's a very commonly missed subtopic, given the fact that the chest fly debate was able to go months without being noticed. I had it in my notes before I even moved to Texas, as this is a video that I want to talk about because it is wrong. And the reason I waited so long to talk about it, well, there were two reasons. One, I wanted to see how many creators would jump on the bandwagon just because TNF said something. They're going to get behind it, and it was a lot. And that just tells me who is actually thinking about things critically and understands topics, and who's just kind of hopping on bandwagon of other creators. The other thing I was curious about, the other reason I waited so long is because I knew that video was going to be my big video. I'm proving TNF wrong, so I really wanted to make sure that everything that I said was factually correct and stated as properly as possible. So, I mean, yeah, but it did show just how many people are lacking in the physics space in this industry because I don't want to say fairly simple concept because it is a more complex topic. This is a physics 2 level topic. But still, nobody was able to catch it for months. So it really shows that there's nobody in this niche, and I'm so glad that I get to be the guy that fills it because it really is a passion of mine. I love physics.
Yeah, it seems like you are the go-to guy for physics in the science-based lifting niche. Like,
yeah, super cool. I mean, I'm getting tagged in videos every day of people being like, "Why is this machine so easy? Oh my god, I maxed out this machine. I don't get it, Baxum. Please help." And I'm like, "Yes, dude. Oh my god, I'd love to help you. That's amazing." Yeah, it's awesome. I love it.
yeah, I mean, that's the thing that I really want to stress to any viewer that's come across any content that's in the science-based lifting niche. You have to take the time to critically think about these concepts yourself. It has to make sense to you. Spend some time trying to prove yourself wrong. Because
Yeah.
if you don't, sorry, what were you saying?
Oh no, you got it.
No, I was saying you have to spend some time proving yourself wrong, trying to find evidence that refutes the current philosophies that you have, because that's the only way we actually grow as researchers. And what we're doing is researching.
Yeah, and being wrong is a good thing, guys. It is absolutely amazing. We have this huge problem, not just in the science-based lifting community, but in society in general, where being wrong is a bad thing. People are afraid of being wrong. You need to accept being wrong and being willing to change your ideologies when you're wrong. And I'm really seeing it in the science-based lifting community, where when people are wrong, they are afraid to admit it. And a lot of people actually unfollowed me when I made a video saying I was wrong. I know we talked about this earlier, but I recently made a video saying walking up a treadmill is easier than walking up a hill. And when I was proving this point, I made some incorrect physics principles. That's right, the physics guy got something in physics wrong. And I talked to a few other creators, the primary one being Josh Nabby, and we went back and forth. And Josh was insanely helpful. And at the start, he's like, "Yeah, nah, dude, I think you're wrong here." And then he's like, "Wait, no, dude, you're right." And then, "Oh, no, you're wrong." And we were going back and forth until finally I was like, "Hey, Josh, when I get off work, I'll work this out." So I worked it out, and I was like, damn. The final equation was negative mgh treadmill equals negative mgh hill, meaning both are equal, and I was wrong. And I had to take my video down and make a video saying, "Guys, I was wrong." And that is not easy, but it is so important to do, because if you don't do that, then people will not be able to trust anything that you say, because they never know when you're wrong and when you're right. And that's something that I really was ridiculing Yo about during the chest fly debate, which was, I think you will look a lot better if you just admit you were wrong, and it's something that he disagreed with me on fairly rudely, in my opinion.
Yeah, I think I would definitely agree that accountability is one of the biggest and most important things that a creator needs to have if they're going to be educators. If you're going to try to teach people things, you have to take the responsibility when some of the education that you give out is based on misinformation. And the problem that happens, we spoke about this in the previous episode, but creators sometimes build their followings off of certain philosophies, certain viewpoints, and as they grow as people, their followers are with them because of the original philosophy that they had. So if you become popular preaching a certain method of doing things, and you've built this fan base based off of the way that you've taught people, it's very hard to contradict yourself and go back on the statements that you've made. But in order to be genuine and to find the actual closest thing to the truth that we can, we have to admit when we're wrong.
Yeah, absolutely agree. And I actually lost followers in that treadmill video. Like, if I look at my analytics, it's a negative number. It's not the original one where I was wrong, but the one where I said, "Hey guys, I was wrong." And a few of the comments were like, sorry, I'm getting a call. A few of the comments were saying, "I just can't follow you if you're going to be wrong like this." And the truth is, everybody's going to be wrong. I'm glad those people aren't following me anymore, because if you were expecting perfection out of a human being, that is an unreasonable expectation. I was wrong, I admitted it, and I will be wrong again, and I do admit that. But there's two things you won't see me do on my channel. The first one is try and debate a topic that I have no knowledge about. If I don't have knowledge on something, I will tell you I do not have knowledge on this. And the other one is, if I am wrong, I will make multiple videos saying I was wrong, admitting I was wrong, and explaining why I was wrong, and I will not delete the video and try and blow smoke up your ass that I was right the entire time.
And the only thing I wish that we could have gotten out of this conversation was the 2 hours that we lost in the beginning, because
yeah, it was beautiful.
It was honestly, yeah, I don't think we'll ever be able to recreate those first 2 hours. But regardless, that was an awesome conversation, dude. I think people are gonna walk away from this episode with a lot to think about. I appreciate you taking your time to share your perspective twice with me. We've been recording for like 4 hours now at this point, maybe like 3. Putting out some of the sharpest stuff out there. You want to drop your socials for anybody? It's at Baxum, right?
Yeah, I'm just at Baxum on TikTok. I really should branch out more than that. I got a YouTube coming soon.
All right.
Awesome, man.
I'll see you guys in the next episode.